So, once again, you are welcome. Let us now continue from where we stopped. We have talked about the hypergeometric distribution, which is a distribution for sampling from a finite population with two classes, and you are sampling with replacement. You are sampling with replacement. That is part of it. You are sampling with replacements in the hypergeometric distribution. Now, we have discussed some of the properties of the hypergeometric distribution, that the mean is equal to NP. The second moment is given by K into bracket N, Kn rather, into brackets Kn minus N minus K plus capital N all over N minus 1. So you should have the notes by your side to be going through it as I'm discussing. And that the variance of the binomial, of the hypergeometric distribution is also, it's given by NP to bracket 1 minus P, all multiplied by capital N minus small n all over N minus 1. And as N, capital N, that is the size of the population, becomes very large, this value gets close to the binomial, the variance of the binomial. So the hypergeometric distribution, the limit of the hypergeometric distribution is the binomial in terms of the variance. In terms of the general behavior, actually, the mean and the variance, and as an explanation, when the samples or the population size becomes very, very large, then whether you are sampling with replacement or sampling without replacement, there is no difference. Take note that for the hypergeometric distribution, you will be sampling without replacement for a situation that has only two possible options: success or failure, male or female, membership of a committee or not a member, and so on and so forth. Even in situations where you have more than two categories and you are interested in studying a particular concept, you can break it, you can group every other group into a particular category, and the category of interest will be on its own. So you can always break it into two groups, even if there are more than two at any point in time. So let us look at the first example that is given in the write-up. That is example 1. That is the write-up that we have sent to you earlier on, the note talking about hypergeometric distribution, example 1. It is on page 5. What I'm saying is on page 5. Have we seen that? Example 1. Please, if you have seen it or you have it, just put a comment on the chat to make me know that you have access to that note. The main note, example 1 of it, page 5 of the main note. Make your comments to say that you have it or not. Yes? Good. You can see it. So we are talking about example 1. That suppose there are 4 defective items in a box that contains 30 items. What is the probability that a random sample of 4 items from the box will contain A, 2 defective items, B, at least 2 defective items, and C, 4 good items? Now, the question you should know straight away that it is an hypergeometric distribution that is applicable to it. First of all, you are told that there are 4 defective items in a box that contains 30 items. So the box contains 30 items, out of which 4 of them are known to be defective. 26 of them are not defective. So capital N in this case is equal to what? Put your comment there. What is capital N equal to? Comments. Capital N is equal to what? And capital K is equal to what as well? Quickly, capital N is equal to yes, capital N is equal to 30. That's correct. Then capital K is equal to what? K is equal to 4, correct. So that is understood. So the first 4 there is the capital KO. We should take note of that. That there are 4 defective items inside the box that contains 30 items. So the solution is we have been given that capital N is equal to 30. Then small n, that is the size of sample. That is the next sentence in the question. The first sentence was suppose there are 4 defective items in a box that contains 30 items. That has provided you the information of capital K and capital N. The next statement is what is the probability that a random sample of 4 items, so the sample size is small n and is equal to 4. Now, from that sample, we are interested in whether there are 2 defective items or at least 2 defective items, then 4 good items. Let us go one after the other into it. The first one, the first solution, we are looking for probability of x is equal to 2, where x is the random variable representing the number of defectives in a sample of size n drawn without replacement. It is without replacement, even though it was not specified here. You should know that it is without replacement. So it doesn't need to be specified directly. Implicitly, you will be able to determine whether it is with replacement or without replacement. For example, if you want to choose 4 members from a committee to form a committee of 4 from a class that contains 10 males and 15 females, you will know that that is sampling without replacement. You don't need to be told that it is with replacement or without replacement, because nobody can be represented twice. in that membership of that committee, every individual can only represent himself once. You cannot say Mr. A is the chairman, that is number one, and Mr. A is also the secretary of that committee, number two, that is representing two people. It's not done that way. So whenever membership of committee, picking of individuals is talked about, you should know implicitly that you are talking about sampling without replacement. Moreover, the size of the population was given. In that case, capital N is given. So that is the case. So probability of X is equal to 2 is just using the formula for the PMF of the hypergeometric distribution, where you have the formula that has been earlier given, that probability of X equal to, or P of X is just equal to K combination X multiplied by N minus K combination small n minus X all over capital N over small n. The combination of capital N, that is capital N combination small n. That is the formula for the PMF, rather, probability mass function. Who is that is disturbing us?
Speaker, yes. And also,
So let us continue, please. Sorry for that. Let's continue. So we are talking about example 1, solution, the A aspect of it. So probability of X is equal to 2 is using that formula. So you have 4 combination 2 multiplied by 30 minus 4 combination 4 minus 2 all over 30 combination 4, which when we do the computation, as we said, combination is just a relationship, factorial relationship. So it's the final answer is 0.071, which you can verify straight away. 0.071. That is the probability that if you draw a sample of size 4 from that box, which contains 4 defective, the probability that you have exactly 2 items to be defective is equal to 0.071. The next item is probability at least 2 defective items. That is probability of X greater than or equal to 2. That is, X will go from 2, 3, and 4. So you have to sum the probabilities for 2, 3, and 4. And you have to get the various probability, P of 2, P of 3, and P of 4. So we have already obtained P of 2 to be 0.071. So P of 3 will now be given as the same, even when we use that recursive formula. The recursive formula earlier on in page 4. and also explained in yes, in page 4. There's a recursive formula that P of x plus 1 is equal to k minus x multiplied by n minus x multiplied by P of x all over x plus 1 multiplied by n minus k minus bracket n minus x minus 1. I hope we have seen that is in page 4. Page 4, that recursive relationship. You can use it to obtain subsequent probabilities. So since we already know P of 2, we can have P of 3, we can have P of 4, and so on and so forth. So that is the way to go about it. So we use that to obtain P of 3. P of 3 is given as in fraction 104 over 27,405. Likewise, P of 4 is also given as 104 over 27,405. So that when we add the three probabilities together, P of 2 plus P of 3 plus P of 4, it will yield for us the total of 2,158 over 27,405, which is in decimal equal to 0.0787. That is the probability that in that sample of size 4, that you have more than 2 defectives, either 2 or 3 or 4 defectives, is equal to 0.0787 or approximately 0.08. In essence, if you want to put it in terms of percentage, we are saying that there is about 8% chance that you have above 2 defective items in that sample of size 4 that you have drawn from the box that contains 30 items and four defective of them. So probability of x is equal to 4. Probability that x, that is it, that you have at least 2 defective items, is just given as 0.0787. Or rather 104, no, 0.0787, yes, correct. Then the third item, the third option is probability of having 4 good items. Now, if you have 4 good items, how many defectives will be there? Put your answer in the comment quickly. If you have 4, if you draw a sample of size 4 and there are 4 good items, then how many defectives will it have? 0, correct. There will be no defective. So what you are interested in is just P of 0. P of 0, which we have given the formula is n minus k combination n all over capital N combination small n. That is to say that it is equal to 26 combination 4 all over 30 combination 4, which upon resolution is 14,950 over 27,405. That is that's the relationship, or I mean the probability that there will be 4 good items. That is probability that there will be no a 0 defective. And it is very high. If you can see it, it is 0.5455 or approximately 0.54. in terms of percentage, it's telling us that there's a 54% probability or chance that when you draw a sample of size 4 from that box that contains 30 items, which in the box you have 4 defective out of that 30, then if you draw a sample of size 4, there is a 54% chance that there will be no defective among that sample, that you have 4 good items. That is the implication of that. So that is the way to go about computations for hypergeometric distribution. We can also do several other ones. You can have probability that all the 4 items will be defective, which we have already given as P of X, P of 4, and is equal to 104 over 27,405. It's a very small value. It's a small value, and that's that for that. So, any question on that? Any question? Put your comments. I will see it now. Any question? Put the comments. What's your question? What is the question? Your specific question, please. What is the specific question that you have to ask? Yes. P of S is equal to 4. It's the same formula for the MF. You just put S is equal to 4 in wherever you see X, you put 4. Wherever you see X, you put 4. That's how to compute it. The PMF on page 4 of that on page 4, the PMF is given as P of S is equal to S, which is also P of S, is given as K combination X multiplied by capital N minus capital K combination small n minus X divided by capital N combination small n. So you only have X at the numerator. The first combination, K combination X, and the second combination, N minus K combination small n minus X. Is it possible to have sampling with replacement using hypergeometric distribution? No, it is not possible. Once you are using hypergeometric distribution, in essence, you are sampling without replacement. So the probabilities of success, what makes it to change is that the probability of success is not fixed. For the example that we have talked about now, looking at it, you have 4 defective elements in the population, 4 defective items out of 30. What is the probability of success? That is the probability of picking a defective item whenever you draw anything from that. When you pick an element randomly from it, what is the probability that it will be defective? It is 4 over 30. It is 4 over 30. So 4 over 30 is the probability that you will have a defective item when you draw a sample from it. Now, that 4 over 30 is not fixed. If you have conditioned it that when you draw that first item and it is defective. How many items will now, and you are not replacing it back. You are not replacing it back. How many items of defective will you be left in the box after you have drawn the first defective? When you remove one defective from the box, you will be left with 3 defectives and 26 correct or good items. So the probability in the second draw of picking a defective will now be 3 over that 29. 3 over the total number of items still left in the box. 3 over 29. So it has changed. That probability of success has reduced. As you are picking defectives, the probability of success continue to change. But in the case of sampling with replacement, the P, which is 4 over 30, remains fixed because whatever you do, you replace it back. So essentially, that is the difference between sampling with replacement and sampling without replacement. But as I said, when the population becomes very large, there is no difference again. For example, if you have 1 million items inside, out of which maybe 1,000 of them are defective, or let's say 100 of them are defective, there will be no much difference between 1 over, the probability of success, even when you are removing from when the sample size is gradually decreasing, because the population is very large. So that is the essence of the hypergeometric. You are talking about a finite population and you are sampling without replacement. So that is essentially why the probabilities, they alter. But as the population becomes very large, then you cannot, the hypergeometric distribution will now approach the binomial. They will now be similar because sampling with replacement and sampling without replacement, essentially they are the same way. When you have a bigger size or a larger population. So that is the answer to that question. Any other question? Any other question? I will also provide you explanatory notes that will further and other examples for us to understand the concepts more. So I will do that in due course. So I will give that to you and pass it to you. So let us look at some of those exercises and give you an hint on how to go about them so that you are able to look at them and solve them. The first exercise, it says an urn contains 5 red and 45 black balls. A random sample of 10 balls is drawn from the urn without replacement. Compute the following probabilities. A, the probability that you have 4 red balls. B, the probability that you have 5 red balls. C, the probability that you have at most 2 red balls. And D, the probability that you have at least 5 black balls. Now, how do we go about this one? They said an urn contains 5 red and 45 black balls. Your interest is on the red balls from the questions that have been given mostly. A, red balls, B, red balls, C, red balls, then D, at least 5 black balls. Now, at least 5 black balls is telling you is also equivalent to at most 5 red balls. Because, so n is 50, correct? Capital K is 5 and small n is 10. So that is correct. You can now use that to solve all the various problems. Let us look at the D1 that is talking about black balls. At least 5 black balls. It means 5 from 5 black balls upwards. That you have 5 black, 6 black, 7 black, 8 black, 9 black, and 10 black. So from 5 black balls upwards, from 5 to 10. You know the sample is size 10. So the probability of having 5 black balls up to 10. But your interest is on the red balls. So the probability of having at least 5 black balls is telling you that you cannot have more than 5 red balls. So if you structure it back into your own the variable of interest, what will be the probability? Write it out. The probability of, in terms of red balls, put the comment there. Restructure the D question to the probability in terms of red balls, which is what we are concerned with. It has 5 black, 5 red, and 45 black. Yes, at most 5 red balls. That is, P is less or equal to 5. It cannot be greater than 5. Is less or equal to 5. So you have P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. Please let us go back to example 1. Example 1. Please take note that P of x greater than 2 is given by P of x equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. But P of x less than or equal to 2 will be equal to P of 0 first plus P of 1 plus P of 2. Take note, P of 0 is also a probability that you must factor in. So in this case, our interest for the D will be P of x less or equal to 5. So it will be P of 0 plus P of 1 plus P of 2 plus P of 4. That will be the probability for that D question in number 1. The second question, there are 36 states in Nigeria, including the Federal Capital Territory. Each state is represented by 3 senators in the Nigerian Senate. And the FCT has only one senator. Now, a group of 20 senators is to be chosen randomly to visit the president to discuss some issues of burning importance. The first question is, what is the probability that the 3 Kwara State senators are among those chosen? The next question, B, what is the probability that neither of the 3 Kwara State senators is selected? Then C, compute the mean and variance of the distribution. How to go about it? The A aspect, first of all, we have to identify all the parameters that have been given from the data. You take note that there is no mention whether this is sampling with replacement or without replacement. So implicitly, you will know, being membership of a committee, somebody cannot represent himself more than once. So it is sampling without replacements. And in that instance, each of all the individuals, they can only show up once in the sample. Now, what are the details of what are the parameters that we are interested in? Capital N is equal to what? Capital N is equal to what? Again, capital N is equal to what? 109. How did you arrive at 109? Show how you arrive at 109. 109. Yes. 109 is obtained by multiplying. From the statement, we have details about capital N, even though it was not stated clearly. You have 36 states. Each of them have 3 senators. So 3 times 36 will give you 108. While the FCT has only 1 senator representing it. So 108 plus 1, the 37th state as it were, or FCT, will now give you 109, which is the number of senators in the Nigerian Senate. You have 109 of them. Capital N is equal to 109. Capital K is equal to what? Capital K is equal to what? Capital K is equal to what? Nobody has gotten it yet. Yes, capital K is equal to 3. Why is it 3? Why is it 3? Please give your reason why capital K is equal to 3. Why is capital K equal to 3? No, you have not gotten it exactly correctly. Oh. What is the variable of interest? Excuse me. The variable of interest is Kwara State, and it has only 3 senators. So out of the 109 senators, you can only have 3 senators from Kwara State. That's why capital K is equal to 3. Because we are talking about Kwara State. Take note of that, please. It is because of Kwara State that we are talking about. It can as well have been any other state. It can as well be any other state. But our interest at this point is on Kwara State. So capital K is equal to 3. Small n is equal to what? Small n is equal to, small n is equal to 20, correct? Small n, the size of the sample, is 20, which is the number or the size of that committee that is going to visit the president. So small n is 20. X is the Kwara state senators. So what are the values, or X is the number of Kwara State senators that may be randomly picked to be part of that committee to visit the president. What are the possible values of X? X will take values, list out the values that X can take. The values that X can take. List them out one after the other. List all the possible values X can take. All the possible values X can take. Correct? No. No. Adeboye, you are not correct. Ubeidat, you are correct. 0, 1, 2, 3. 0 to 3. Those are the values X can take. X can be 0, it can be 1, it can be 2, it can be 3. When it is 0, that means there is no Kwara State Senator in that committee. When it is 1, you have only one Kwara State Senator in the committee. When it is 2, you have 2 Kwara State Senators in the committee. And when it can only be 3 because there are only 3 Kwara State Senators in the whole of the Senate. So you cannot have more than 3 Kwara State Senators in that committee. So the probability that you have 4 Kwara State Senators in that committee is equal to what? The probability that you have 4 Kwara State Senators is equal to 0. It's non-existent. What about the probability that you have 20 Kwara State Senators in that committee of 20? What is the probability? It will remain 0. Yes, you are correct. Adeboye, you are correct. The other people who stated 0. So that is the correct answer to it. Excuse me. So having known that, you can now proceed to obtain the probability that the 3 senators will be selected, which you just P of 3. The first solution is P of 3. You put 3 into that formula for PDF, put all the various parameters and compute. You will have P of 3. Then the second question is telling you that what is the probability that neither of the 3 Kwara State senators is selected? What is the probability that we are interested in that instance? It is P of what? The probability that neither of the 3 Kwara State senators is selected is represented by P of what? Yes. Somebody said P of 17. Somebody says P of 0. P of 17 or P of 0. Which do you choose? No, it's not 1 minus P of 3. It's not. It's not P of x greater than 3. It is P of 0 specifically. The probability that there are no Kwara State senators in the committee that is being sent. There are no Kwara State senators in that committee. It is P of 0. So that is what you will compute. So you put in x is equal to 0 into the PMF formula and obtain your value. You have to verify quick, you have to do it carefully so that you will not get a wrong result. Now, the other question is say find the mean and variance of the distribution. We can easily do this one now. What is the mean of that hypergeometric distribution that we have there, where small n is equal to 20 and p is equal to what? What is p equal to? The value of p is equal to what? In terms of fraction, p is equal to what? Yes, quickly. Yes, p is equal to 3/109. 3/109. So that NP is equal to 20 times 3/109. That is NP. So the variance will be equal to what? I leave that to you to do that, as well as the other ones that have been specified there. So the third question in that example is that Professor Jack Daniels provided 12 questions for a mock exam and hinted the students that the actual exam will consist of 6 questions randomly chosen from the 12. A student by name Kramer decides to memorize the solutions to 8 of the 12 questions. He memorized 8 of them. If Kramer cannot solve any of the other 4 problems that he did not memorize, what is the probability that he's able to solve 4 or more problems correctly in the main examination? Now, this is also an example of an hypergeometric distribution where you have capital N is equal to what in this case? And we also know that it is not sampling with replacement, it's sampling without replacement. You cannot say you want to write STAR 222 exam and you now pick number 1. In the instruction for the exam, you are told to answer any 4 questions out of 6. Now you know number 1 very well from beginning to end. All the details of that question, you know it. And you sorry. So as I said, you cannot answer number 1 question 4 times and say you have done the exam correctly. If each question gives you 20 marks, how many marks will you get in that exam if you answer number 1 question correctly and you repeat it 4 times? In the first page, you answer number 1, maybe page 1 to page 2, you answer number 1. In page 3 and 4, you also repeat number 1 question and you answer it. And you did it 4 times. How many marks will you get from that exam? $20 marks for each question that you have answered. You have 20 marks for each question. And you were able to answer question 1. You got 20 marks on that question 1. You now repeated that question 1, the solution to question 1 4 different times inside your answer booklet, what is the total amount of marks that you get from that exam? Yes? You get 20 over, in fact, it may even be less than 20 over 80 because you have gone against the rule and you may be penalized even at that. You may be penalized and they may subtract from even that 20 that you have gotten. Maybe they will charge you 5 marks or 10 for not answering the question according to instructions. So you cannot pass that question. You cannot pass that exam in that regard. So it is in this light that we have this kind of situation. Even though sampling without replacement is not mentioned, you know that the question that the student is speaking to memorize, they are separate questions. He does not memorize question 1 several times and say that he will answer it many times for him to pass that exam. He must be able to answer 4 distinct questions for him to get full marks or good marks in that examination. So capital N in this case is equal to what? Capital N is equal to what? Capital, we are through with that. Let us go to the answer, the question 3 now, the details of that question. Capital N is equal to 12 because the prof has given them 12 questions. The population of questions available for the prof is equal to 12. So it is equal to 12. Now, what is capital K? It's capital K. Capital K is equal to 6 because the prof has said that out of these 12 questions, he's going to randomly pick 6 of these questions, rather, 6 of these questions are the ones that will come out from the exam. Only the prof knows the 6 of them that he will pick. Every other person, including Kramer, the student, does not know the actual 6 of them that he will pick. So capital K is equal to 6 in this instance. What about small n? What is small n? The size of the sample, what is small n? Why is, give your reason, any number that you choose, give reason why it is like that. Some people are saying n is equal to 8. Why is it 8? Why is n equal to 8? Yes? Why is n equal to 8? Any comment, any answer to that? Yes, because you are interested in the student Kramer. He has picked 8 questions out of the 12 that is available for him to memorize, so as to increase his chances of getting maximum marks in that examination. You know, if he picked 8, then the highest amount of the questions that he will not have touched that will come out is what? If he has picked 8 out of that 12, then it means that at most only 4 questions that he will not be able to solve. That is on the condition that those 4 that he did not pick are part of the questions that the prof will set as the exam. So he is guaranteed of 2 questions at least. is guaranteed of 2 questions that you'll be able to answer correctly by cramming that number of questions. By cramming 8, he is guaranteed at least 2 questions that he will answer correctly. Then 4, there is under probability. With certainty, he will answer 2 questions correctly. Sorry for that break. So with certainty, he has 2 questions that are guaranteed for him to answer in that exam. So you now know all the parameters. So the question is now, if Kramer cannot solve any of the other 4 problems that he did not memorize, what is the probability that he is able to solve 4 or more problems correctly in the main examination? What is the probability that he will solve 4 or more questions? That is 4 questions or more in the exam itself. Now, X will take what values? X will take values between what and what? List out the values that X can take. X is the probability that Kramer will solve the number of, is the random variable representing the number of questions Kramer will solve correctly in the exam. What are the values that X will take? No, we have not gotten that. Four, five, six. No, that's not correct. It cannot be up to. Let's look at the question properly. The prof provided 12 questions for a mock exam and gave them hints that the actual exam will consist of 6 of those questions. Okay, randomly chosen from the 12. So only 6 of those 12 will come out in the exam. Now, a student memorizes 8 out of these 12 questions. Then it's now stated that if he cannot solve any of the other 4 problems that he did not memorize, what is the probability that he is able to solve 4 or more problems in the examination? The probability that he will be able to solve 4 or more problems, that is from 4, 5, and 6. P of 4 plus P of 5 plus P of 6. Now, you should know that the way the question is structured, there is no possibility that the probability that he will not be able to, will be unable to solve 0 questions is 0. P of 0 is 0 in this instance. So the thing starts from 3. He can solve, he can certainly solve 1, 2, 3, 4, 5, or 6 of all the questions. So let us go and look at the question very well. It's a bit technical, but you can be able to maneuver yourself over it. having known all the necessary parameters that are involved. So there is also the hypergeometric test. The hypergeometric test. It uses the hypergeometric distribution to measure the significance, statistical significance of having drawn a sample consisting of a specific number of successes out of n draws from the population size n, which contains capital K successes. So it is one of the tests that can be used in relation to the hypergeometric distribution. So all the explanations there are, you take note of that. Now is the subheading order of draws. That the probability of drawing any sequence of red and black balls depends only on the number of red balls and black balls, and not on the order in which they appear. Really, that is what is being explained. So in essence, they are saying that even if you draw, if you have a sample of size small n, of which x of them are red balls and n minus x, that is small n minus x in the sample, are blue or black balls. Now, it is saying that the sequence, for example, let's take small n of size 5. If we want to draw five balls from the on, we are not interested in the sequence. Red first, maybe red, red, blue, 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 or red, 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 and so on. The interchangeability of the draws is what is captured by the hypergeometric distribution. So it is called an exchangeable distribution because it is not dependent on the sequence of the draws. It's not dependent on the sequence of the draws. Whether you draw, for example, if you want to draw the probability of drawing 3 balls, I mean a sample of size 5, 3 red and 2 blue. You have 3 red and 2 blue. So you can have red, 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 blue, blue. That is one sequence. You can have red, blue, blue, red, red, another sequence, and so on. The 2 blue can come first, blue, blue, then red, 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 blue, red, red, blue, and so on. That sequence is of no importance when you are making use of the hypergeometric distribution. When you are making use of the hypergeometric distribution, the sequence is of no relevance. So it is called an exchangeable distribution. Then the table that we have given there is the distributions that can be related to the number of successes in a sequence of draws. Now, if the random variable is the number of successes and you are sampling with replacement, the correct distribution is the binomial distribution to use. If the random variable is the number of successes also, and you are sampling without replacement, the correct distribution is the hypergeometric distribution on the condition that the population is finite. Because if the population is not finite, then the distribution will also be binomial because the probability of success will not change across the draws. But if you are now talking of the number of failures until the first success, for example, the number of times a student will write JAMB and fail it until he get enough score to make him to gain admission into the university. If that is your interest, the number of times he failed it before he became successful, then you are talking about if you are sampling with replacement, you are talking about negative binomial distribution. But if you are sampling without replacement in the case of writing JAMB exam and failing it and try to write again and again, that is an example of sampling without replacement. The negative hypergeometric distribution will be applicable to it. to the negative hypergeometry. So you have binomial hypergeometry, the negative binomial and negative hypergeometry. So binomial and hypergeometry, they are when you are concerned with the random variable number of success. Sampling with replacement binomial hypergeometry. Of number of failures until the first success. The negative binomial distribution is for sampling with replacement, and the negative hypergeometric is for sampling without replacement. A question that I want to ask, if you are sampling, if you are talking of number, so that is the summary of distributions in random experiment. The geometric distribution has a form of relationship with all these ones, but let us leave that out. Any question? We shall now be moving to the multinomial distribution, which we shall take in the next class. And I expect you to go through it, go through the notes, so that if there are questions that you will ask me in the next class, you would have gotten your questions correctly. You don't have the notes. You can get the notes from your colleagues. Let them give you the way to get the notes. Meet your colleagues and let them give you the means of getting the notes. It is available. Any other question? Any other question? So you can always have you can always go through the this lecture that you have had. You can always go through it again on that Facebook YouTube channel. Is there. If you want to watch it again and so on, you can always do that there. So as I said, thank you very much. Always maintain comportments in the class because it's being recorded so that you will not be found on the wrong side. Nehemiah A. Ikoba is my name is the channel. Nehemiah A. Ikoba. Just search for it on the YouTube. You may also subscribe so that you will be notified anytime any new video is out there. Any other question? I hope you heard me clearly this time around. Good. So see you tomorrow by God's grace.